Today we're going to start by learning how to solve a system of equations by graphing. Now we've done this before when they were in slope-intercept, but this time they're going to be a little different because they are in standard form. So we're going to have 4 steps. Step 1, rewrite into y equals mx plus b form. That's slope-intercept. 2, graph both lines. 3, we're going to find the point of intersection. Remember, that's where they cross at. And 4, we're going to check the point to make sure that it works. So the first example we are going to do is negative 2x minus 2y equals 2 and negative 4x plus 4y equals 2. In order to do this problem, we first have to start by rewriting the equations. So I'm going to do the first equation. I'm going to go ahead and do it in red. I'll carry it down here so that you can see it. You would use your graphic organizer to rewrite it if you have a graphic organizer. So what we do is we start by adding our 2x over. So we have negative 2y equals a positive 2x with a positive 2. Remember that since it's a positive 2, you put an addition sign. We divide everything by negative 2. You can break it up or you can divide the whole quantity by negative 2. And we're left with y equals 2 divided by negative 2 is negative 1x. And 2 divided by negative 2 is negative 1. So now at this point I could go ahead and graph, which I'm going to, and then I will graph them both when it's all said and done. So we start with move. This is how we move. This is where we begin. We're going to start at negative 1. We're going to plot a point. A slope of negative 1 means we're going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And then using a straight edge, and this method is very important to do so, you need to make sure that the points are straight. You're going to use a ruler, and you're going to extend your line forever. Now mine, I'm going to have to adjust a little bit in order for it to work out. But we get a line that looks like this. Make sure that your line is nice and long. Make sure that you've extended it and put arrows on the end because it extends on forever. So there's my first equation, or my first line. My second line, I'm going to do the exact same process. This time I'll do it in blue. So in order to do this problem, we have 4x over first, so we get 4y equals 4x minus 12. We divide both sides by 4 because it is a positive 4y. And we get y equals 4 divided by 4 is 1, so 1x minus 12 divided by 4 is 3. So now I can graph it, move, begin. I come over and I graph it, so negative 3. A slope of a positive 1 means it's going to rise, so we're going to go up 1, right 1, up 1, right 1. Now did I plot that point at the right spot? Actually, I didn't. If you look at it, I went to negative 3, so I need to move those points up just a little bit. We're all human, we all make errors. Up 1, right 1, up 1, right 1, up 1, right 1. Then using my ruler, I come through and I draw my line. I put my arrows on the end of my line, and that represents my second line. Now the solution to this problem was where those two intersect at. So if you look at this problem, the point where they intersect at is right in here. Now that ordered pair, if we write it as a set of ordered pairs, would be the following. Let me switch back to my writing utensil. We go right 1, down 2, so 1, negative 2. And it's really easy to check it. All you have to do is plug it into both of your equations and make sure it works. So I'm going to start by putting it into my first equation. So I'm going to write in a different color here. Where I see an x, where I see a y, I'm going to put in both of them. Now you could put it into the reduced one, but I'm just going to put it in the original. So negative 2 times my x, so 1. And then it says minus 2 times my y, which is negative 2, equals 2. And I'm going to check it and make sure it works. Order of operations, say I do multiplication first, so negative 2 times 1 is negative 2. This is like a negative 2, so negative 2 times negative 2 is a positive 4. And negative 2 plus 4 equals 2. So that does work. That one checks, but it has to work in both. So I repeat the process for the second one. Negative 4 times my x, which is 1, plus 4 times my y, which is negative 2. The question is, does it equal negative 12? Negative 4 times negative 1 is negative 4. 4 times a negative 2 is negative 8, and a negative 4 and a negative 8 make a negative 12, which means that works as well. So since it works in both, here's our answer to our problem. Let's try another one. We have 3 examples to do. That was example number 1. Example number 2. Okay, so we repeat the process doing the exact same method we did before. So step 1, we rewrite it. Now you could, if you knew how to do your intercepts, you could do it that method. But since we haven't talked really about finding your x and y intercepts, we just rewrite it. So I have negative 4y equals a negative 4x minus 4 because I subtracted 4 from both, negative 4x from both sides. Divide everything by negative 4. And I get y equals negative 4 divided by negative 4 is 1, so 1x plus 1. Well, that one's pretty easy to graph. We start at 1. We rise 1, run 1, rise 1, run 1, rise 1, run 1. Then using our ruler, we come back in and we play connect the dots, extending the line infinitely in both directions, and then we put arrows on the ends. I'm going to repeat the process this time with the second equation as well. It says negative 2x, so I add 2x to the other side. So we get 6y equals 2x minus 6. And this time I'm going to divide everything by 6. So I get y equals 2 divided by 6 is 1/3 x, and 6 divided by 6 is 1, but it's a negative 1. So this time what I'm going to do is I'm going to start at negative 1. I'm going to go up 1, right 3, or I could go down 1, left 3. I draw my line in as best I can. I put my arrows on the end. And now I can look for the point of intersection where the two overlap at or cross, which is right here. We find that ordered pair. And that ordered pair, it looks to be negative 3, negative 2. So we're going to write negative 3, negative 2. And we're going to test it in both of the equations. Now remember, you can test it in a reduced one, which is these in slope-intercept, or you can test it in the original. I'm just going to test it in the original. So 4 times my x value, I'm going to use parentheses this time. Remember, parentheses is just another way to write multiplication. Minus 4 times negative 2. The question is that equal to negative 4? 4 times negative 3 is negative 12. Negative 4 times negative 2 is positive 8. And negative 12 plus 8 is negative 4. So it works in the first one. Now what happens if it doesn't work? Then you did something wrong and you need to recheck your math. Probably check your graphing first of all. Make sure your slopes are both positive or negative. Negative 2 is my second equation times my x, so negative 3 plus 6 times negative 2. The question is, does that equal negative 6? Negative 2 times negative 3 is a positive 6. 6 times negative 2 is a negative 12, so plus a negative 12. That equals negative 6, which is good. So it works on both. So there is my answer. That is the point of intersection. Now remember, if two lines never cross, then it's going to have no solution. But in these cases, they do all intersect. Let's try one more, and then that will be the end. So here's our last one. So I'm going to start by rewriting my equation, adding my 3x over. So I get 6y equals 3x plus 12. I divide everything by 6 this time. And I got y equals 3 divided by 6, which is 1/2. So 1/2 x. 12 divided by 6 is 2. I go over to my graph. I plot 2. I rise 1, run 2, rise 1, run 2. Or I could put my car in reverse. I could go down 1, left 2, down 1, left 2. Using my ruler, I go through all my points, extending infinitely in both directions, and I put arrows on the end. I'm going to repeat the process with my second equation, starting by subtracting my 5x over, so I get negative 2y equals negative 5x plus 4. I do divide everything by -2. If you want to break it up, you can. You get y equals 5/2 x minus 2, because a negative divided by a negative is a positive. Come over to my graph, I plot -2, I rise 5, 1, 2, 3, 4, 5, run 2. Looks like there's my point of intersection. I draw my line, I put my arrows on the end, and then I can figure out where they intersect, which is right here. That ordered pair looks to be 2, 3. And you could go through the same process of checking those, putting the 2 in for this x and the 3 in for y in both, and making sure that it works. I hope this is helpful, and let's get started on today's assignment.